Welcome to Webinar Wednesday. We are excited about today's presentation featuring Keith Herron, Industry and Solution Strategy Director, Chris Clemenson, Technical Customer Architect, and Derek Olson, Senior Director of Development. Keith, Chris, and Derek will discuss the technologies available to meet a variety of use cases across healthcare. These technologies range in complexity, accuracy, and price. The team today will help you determine which technology is best suited to meet your current needs and how to make a plan for long-term value. Webinar Wednesday would like to thank our sponsor, N4. N4 Location-Based Intelligence is an interoperable software platform for healthcare systems, hospitals, and clinics, leveraging real-time location systems. This healthcare-specific solution provides real-time visibility into the movement and management of medical equipment, staff, and patients. For more information, please visit n4.com. A few announcements before we get started. If you haven't already registered for our upcoming MD Expo, there is still time. Join us in Dallas, Texas on April 16th and 17th. Our pre-show planner is available in the in the handout section for download. Please look it over and visit MD Expo Show for details, registration, and our steps to a safe and clean meeting environment. While you're there, please make sure to sign up for our newsletter so that you always have the most up-to-date information and details. Let's give one lucky attendee the opportunity to win a newly designed Webinar Wednesday t-shirt by answering the following question. In what year was N4 founded? You can answer by visiting our sponsor's website. Please use the questions feature in the GoToWebinar dashboard to submit your answer. As always, today's webinar is eligible for one continuing education credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. More details on this at the end of today's webinar. We will wrap up today with a question and answer session. You can submit your questions anytime by using the questions feature on your GoToWebinar dashboard. We will get through as many questions as time allows. Our presentation today will begin with some information from Megan Butler, Clinical Solution Advisor of N4. Megan, you may begin whenever you are ready.
Thank you so much, Jennifer, and thank you all for attending our webinar today. RTLS, RFID, BLE, and Wi-Fi, Unscrambling Locating Technology to Meet Your Short and Long-Term Goals. As Jennifer mentioned, I am honored to have three of my colleagues presenting today's information. And as a clinical solution advisor, it's been my experience talking with potential customers or existing customers that they're often in a predicament of understanding what is the desired use of something like location-based intelligence at their organization and what technology is going to best meet their needs. There are lots of different considerations to take into account, so our aim today is to provide you with some solid information on several different types of technologies, as well as the use cases that location-based intelligence offers in our time today. And Shanna, if you could just progress to the next slide so we can remind everyone for who will be presenting today. And then I will hand it off to Keith Herron, our Industry and Solution Strategy Director, to begin the overview.
So hi, everybody, and thank you, Megan. As an overview, I'd like to first help you understand some of the complexity that drives the need for a technology like location-based intelligence. And as you're all aware, most healthcare organizations run extremely complex operations that are required to manage thousands of individual moving parts, including staff, equipment, supplies, patients, etc., all in an effort to try to deliver optimal care. For example, most hospitals have tens of thousands of individual pieces of equipment that have to be maintained in an operational state, positioned properly to make them available for use on patients, and then properly cleaned after each use. Having the correct equipment in the correct place and time to use on the correct patient is often very challenging. In a similar fashion, a clinic may see hundreds of patients in a day, ensuring that each patient receives proper care while flowing through the various locations and activities while interacting with multiple staff members in a seamless, efficient manner is also often very challenging. And patient satisfaction and staff stress levels are impacted greatly by how well the organization performs on that front. The difficult aspect, of course, to coordinating all these separate components to operate at maximal efficiency is best accomplished by utilizing automated location technology to identify real-time information about these activities so that staff can have current situational awareness of what's happening and when and how they need to act to perform their jobs more efficiently. So Infor's location-based intelligence is an enterprise software platform used by healthcare organizations to provide essential information about the current operational activities and status of their departments, including patients, staff, and the mobile equipment and facility resources needed to optimize the efficient delivery of patient care. So let's click again, Shanna. Our platform integrates with many other healthcare software applications, including electronic health records, computerized maintenance management systems, enterprise resource planning systems, and any type of locating hardware technology that we're going to talk about today in order to supply care providers and management with automatically updated, highly accurate information about the location, status, and activities of any tracked entities throughout their enterprise. Let's click again, Shanna. We have solutions that we've designed to optimize the operations of most major health department workflows, including asset management, environmental monitoring, and patient workflows, including emergency department, perioperative and procedural care, inpatient and behavioral health units, outpatient clinics, and patient rounding. It's possible to install a single solution to meet your immediate needs and then expand over time to install additional solutions as your needs and your budget allow. Let's click one more, Shanna. And of course, we've also provided the subject matter expertise to help you design and install and maintain your locating software to ensure that you continue to get maximal value from your investment. Next slide, please. Our software application uses location data provided by a locating hardware network installed within the healthcare facility. We can accept location data from any type of hardware technology or even a combination of different technologies within the same facility. The key to the value of our location-based intelligence is that it can automatically identify the current location of any tracked entity, including equipment, patients, and staff. No one has to stop what they're doing to enter data to tell our computer systems anything. And by simply having the critical information about location, we can provide so much other valuable intelligence needed to make the work environment more organized and efficient. The amount of value that we can deliver depends greatly on the accuracy of the location data that we receive from the locating hardware technologies that are installed within the facility. So let's take some time now to review the various locating hardware technologies that are available so that you can better understand how they work. I'll hand this over to Chris, who'll take you through that now.
Yes, thank you, Keith. So I'm going to use the next few slides to review some of the locating hardware technologies that can provide location services to an RTLS application, and then how each can provide unique value to system users. Next slide, Shannon. So our RTLS location services technology vendors offer a wide variety of different tag and badge technologies. The purpose of any of the tags is for them to be associated to assets or people, allowing the tag or badge to report their location to the RTLS system. At a high level, tags and badges fall into two categories, active and passive. Active tags have a higher cost of acquisition and ownership. They are more costly to procure during the initial implementation and through ongoing operations when replacing lost or damaged tags. They also require maintenance to replace batteries. The benefits you receive from this additional cost includes more functionality, including the possibility, depending on the vendor offerings, to support more location services signaling technologies. They often provide programmable button presses and can even include things like environmental monitoring. Active tags also have a larger physical profile as necessary to host the hardware required to enable the active tag capabilities. Passive tags have a lower cost of acquisition and ownership due to the fact that they don't require a battery. Passive tags receive their energy from the RTLS hardware device's radio frequency signals. The tags are often printable at a customer site or by a service provider. Passive tags typically have fewer options in the way of functionality, supporting only RFID signals and providing no capabilities in the way of button presses and environmental monitoring. They do provide a much lower profile as they do not need to host the hardware and batteries required for active tags. RTLS hardware vendor tags and badge offerings provide form factor options that are well suited to their intended use. Equipment tags are designed to be attached to assets, typically with a strong adhesive that ensures that they will not fall off. They are often attached via bracket, which makes the actual tag removable for maintenance and replacement. Vendors provide several options for patient badges and staff tags and badges, providing flexibility to customers looking to use them to support a wide variety of different use cases. Next slide. So this slide presents some technologies popular today for providing location services to RTLS. The accuracy capabilities represented show the typical application we see in the market. Keep in mind, the deployment of each of these technologies can be designed to provide different levels of accuracy as appropriate to serve the requirements of the use cases deployed. We'll start at the top with Wi-Fi. Wi-Fi technology is popular in concept because it offers customers the possibility of leveraging their existing network infrastructure deployment without having to deploy dedicated RTLS hardware to provide location services. Where this sounds very attractive, what we've found in reality is a network designed for the purpose of providing Wi-Fi network services does not often provide the density required to achieve usable accuracy required by most valuable use cases supported by RTLS software. In our experience, Wi-Fi is best positioned as a solution to provide a presence level of accuracy, meaning you can tell no more than the fact an asset has been seen somewhere in the facility, or as a complement to other technologies, providing a low-cost option to cover areas that require less accuracy. We'll group the next two technologies, ultrasound and infrared, together due to their similar capabilities. Both leverage active tags, and their signals will not pass through solid walls. Having a signal that is contained within a room provides a reliable method to obtain room-level accuracy. Infrared and ultrasound technology vendors also often offer hardware that can provide blocking signals. These devices allow the technologies to provide bay or chair-level location accuracy and prevent the device's signals from extending through open doors or glass walls. BLE, or Bluetooth Low Energy technology, is an up-and-comer offering. It is an active system with relatively low tag cost and potentially high accuracy. Many of the well-known enterprise network vendors are building these capabilities into their Wi-Fi network hardware, making deployment easier for customers. Accuracy is dependent upon a high degree of density of BLE antennas, so customers are often required to extend their deployed Wi-Fi hardware by complementing their access points by deploying more BLE sensors. In addition to tags, BLE offers the advantage of being present in most current generation mobile devices, opening the possibility of leveraging devices already in possession of staff or patients. This makes another unique application a possibility: the identification of two BLE-enabled devices being in proximity of each other. We found this to be of very popular value in rounding-related use cases. For example, this technology allows an RTLS system to automate a procedure where a healthcare staff member with a mobile device is required to report the fact that they visually observed a patient who is fitted with a BLE wristband. Next, we'll cover RFID, which provides the passive technology capabilities described earlier. With a dense deployment of RFID hardware, the system is capable of providing a very granular level of accuracy, down to bay or chair level. RFID is already popular in many industries and is gaining more popularity in healthcare due to its relatively low cost of ownership after the initial investment. The simplicity and cost effectiveness of tag management is very popular with customers who are concerned with the investment required to maintain their RTLS system. Lastly, UWB, or ultra wideband, is another active system, but it stands out in its ability to provide an extremely high degree of location accuracy. The infrastructure and tags are in the more expensive range of the offerings, and we haven't seen a great deal of UWB in the healthcare market, as its extreme level of accuracy is, quite frankly, more precise than required to support current use cases provided by RTLS. As you can see, there are many options when choosing RTLS location services technologies, and they all provide different strengths to RTLS. Infor recognizes this, and we're eager to help prospective customers choose the technology that best fits their unique requirements. Now we'll quickly review how varying levels of accuracy or visibility can be provided as required by RTLS solutions. These descriptions apply to the deployment models where dedicated RTLS hardware is deployed to provide location services. Locating beacons are typically installed on the ceiling or walls in all areas where patient care is performed. Some, like the beacon on the left, are used for enclosed areas with 4 solid walls. They emit an invisible signal every few seconds that is contained in the walls of the room. Every few seconds, that beacon fills the room with a unique pulse signal that identifies that room separately from all other locations. Other beacons, like the one in the middle, can be used to divide open spaces, such as the double occupancy room seen here, into separate unique locations, allowing sub-room level locating accuracy. Lastly, other beacons, like the one on the far right, can be used to create a small radio frequency bubble around a location to identify any tagged entity that enters that space, thereby providing chair level locating accuracy down to about a 4-foot zone. Next slide, Shanna. All right, now we'll pull it all together using an illustration that shows how locating beacons and badges provide location services to RTLS applications. First, in the RTLS covered room, we need the communications between the locating beacon and the badge. Every covered room will have a locating beacon. It's important that it's installed in a location that ensures it can provide good signal coverage for the room. When a tag or badge enters the room, it communicates with the beacon. And when this communications happens, the event is reported to the RTLS. The RTLS hardware system has systems in place to collect and manage these events. The RTLS hardware system then passes the location change update to the RTLS software, in our case, the Infor LBI system. The RTLS system is configured to create a relationship between the beacon and the location in which it's installed, so it can properly place the tag in the location associated to the beacon itself. Infor LBI is an RTLS application that leverages the location information to populate valuable data repositories and enable powerful automation engines. Infor LBI delivers its value to customers and administrators through a user-friendly, feature-rich, web-based user interface. We also offer multiple mobile applications that provide targeted, convenient access for a variety of user roles. Understanding the varied types of activities that occur through healthcare operations, our system provides multiple options for delivery of the functions and outputs, delivering an optimal experience for end users as they conduct their work. Next, we'll walk through a visualization of this process during a patient visit to a healthcare facility. This animation shows how our software takes data from our hardware vendors and makes this information useful to end users. Staff members and mobile equipment are assigned permanent RTLS locating badges. As patients arrive in a healthcare department, they are assigned a temporary RTLS badge that they wear. During the course of their care, whenever they enter a new location, their badge detects the unique RTLS signal within that room and then broadcasts the RTLS badge's unique ID and the unique location ID of that room to the collecting network. The network then sends the data to our location-based intelligence solution, where we use that information to automatically timestamp the arrival event and update the status of both the patient and the room on our display screens. As staff or equipment enter the room, their badge also communicates their arrival, allowing us to automatically record that interaction with the patient and update our display screens. If conditions are appropriate, our rules engine may also trigger alerts or notifications to further communicate to staff the need for actions to be taken. All of this is done automatically based on RTLS Sense badge movements. Staff members need only wear their RTLS badge as they perform the normal activities of their workday. And with that, I'll hand it over to Derek.
Thank you, Chris. No two real-time locating systems are made the same. Every RTLS hardware provider has built their respective solutions according to what they believe is the best combination of features, function, flexibility, and cost. In order to navigate the breadth and depth and technical financial factors that comes with choosing the best real-time location system, one may choose to invest time and capital to perform in-depth analysis on their own, or one may choose to partner with a trusted advisor. When choosing an advisor, it's critically important that they have hands-on experience in both installing and validating systems representing various types of real-time location technology. An advisor's responsibility is to seek out the best of breed from each technology type, understand the client's specific needs, and help the client navigate the cost-benefit equation to arrive at the best system for their organization. Next slide, Shanna. Evaluating an RTLS involves investments in time to acquire the necessary specifications, build the RTLS and an integration, review business processes and pricing, as well as total cost of ownership. Capital to acquire hardware, computational resources, and software licenses to use for testing purposes. Also, real estate to build a test lab or pilot site that will provide real-world physical challenges. Next slide. In order to understand the strengths and limitations of a given real-time location system, it must be validated against multiple factors, such as functionality, performance, and total cost of ownership. The first factor to consider is functionality. This is typically embodied by the features of the system, such as tag, infrastructure, and software features. Understanding these features is critical to understanding if RTLS can be considered for certain healthcare-specific use cases. For example, if tags are expected to be worn by patients and reused, it will be important to understand how they handle sterilization procedures and common cases of misuse. Other common tag features include, but are not limited to, button press, low battery detection, tamper detection, fall detection, as well as environmental sensing such as temperature, humidity, CO2, and differential air pressure. Some cloud-hosted real-time location systems offer artificial intelligence to smooth and clean tag location movements with the aim of eliminating erroneous location updates. In addition to functionality, the system's ability to perform must be considered. The level of location accuracy is important, but it typically comes at a price. So understanding the accuracy requirements of the use case is an important basis. Some real-time locating systems have been architected to perform batching of location updates, while others have employed time duration smoothing algorithms. These features can reduce the load on compute resources, but they have the potential to delay the location update data to the point where they may no longer be relevant to the use case. The stability of the system is key when considering long-term use and the quality of data it will produce. If the software, tags, or infrastructure is not sufficiently stable, it can cause irretrievable gaps in location data and erroneous location data. Aside from the functionality and performance of real-time locating system, another critical factor is the total cost of ownership. Determining total cost of ownership requires a thorough understanding of hardware deployment design, computational resource requirements, hardware and accessory cost, installation effort, software license cost, service costs, support costs, and maintenance costs. In order to ascertain the total cost of ownership, our team builds mock installation designs for a set of facilities and standard healthcare use cases. Once the designs have been created and all cost factors have been applied, the data from those designs is put into the master data set, where we can determine the total cost of ownership for a variety of use cases, facility sizes, and tag counts. In order to verify system performance and functionality claims, our team designs, procures, and installs the RTLS in our test lab. The software, whether on-premise or cloud-hosted, is configured to collect tag location data from our lab. That data is then routed to a proof of concept integration specifically created to work with the hardware vendor's RTLS interface. Once data from the real-time location system is available, we run a battery of tests designed to uncover its true capabilities and limitations. In addition to validating system performance and functionality, we are also able to determine the complexity of hardware installation and interface configuration, as well as ancillary costs such as mounts, cabling, and special tooling, which impact the total cost of ownership. When combined with historical performance of clients' RTLS installations, we can overlay the ROI to provide a more complete value proposition. Next slide. So as an example, the research team was made aware of a real-time location system that claimed a significantly greater level of location accuracy than competitors of the same technology type. In order to initially validate the claims, the team acquired the system, installed it in the RTLS lab, and built a proof of concept integration that allowed the team to record the raw location data it provided. One of the many tests that this system was put through was an automated racetrack test where the RTLS tag is physically moved along a predetermined path multiple times in a continuous loop. The image shown here is from one of the test runs. The blue line represents the exact true path of the tag, while the orange line represents the raw location data received from the RTLS interface. While we were able to conclude from our analysis that the accuracy claims were valid, however, upon further inspection of the system's total cost of ownership, it was determined that it could not be competitive in the marketplace due to the high cost to deploy and maintain the location infrastructure. The RTLS market for healthcare is rapidly growing and evolving. When new systems, features, and technologies emerge, it is our mission to discover and validate them for application to the healthcare space. Using our knowledge of the best of breed options, we can confidently advise clients who are ready to choose the right real-time location system for their specific goals. Now I'll turn it over to Keith, who will review our test cases, our use cases.
Thanks, Derek. So now that you have a better understanding of the capabilities and some of the limitations of the various locating hardware technologies that are available, let's see how Infor location-based intelligence software can be used to generate value for you. And one thing you have to keep in mind is it's ultimately going to be the use cases that are going to drive your decision as to what hardware technology you want to install into the facility. Because obviously, if you install something that doesn't deliver the accuracy that's needed to meet the use case, then you're kind of wasting money and time, and your project is likely to fail. So let's take a look first at some of the use cases that revolve around asset management, with the simplest of those just being performing a simple search for equipment. So as you're aware, every healthcare organization, whether they're small or large, they all struggle with having rapid access to the equipment that they need, whether that's a nurse who's trying to find all the components of an IV pump so that they can administer a medication to a patient, or whether that's a clinical operations staff member performing periodic inventory or preventative maintenance on thousands of those same types of pumps. This is exactly what locating hardware is uniquely best suited for, is being able to find things quickly. And depending on the level of accuracy of your locating hardware network, we can narrow your search down to an effort that involves maybe a 30-foot zone that you have to look through to find it, or even down to the exact room or subsection of a room where something's actually located. So Infor provides also a mobile locating app that your seeing on the screen now to allow users to identify on a map view exactly where the item is that they're looking for. And if the staff member is also wearing a locating badge, then we can even show their position on the map relative to their desired item. Let's advance to the next slide. We also have a desktop view that you'll see here in a moment. Yes. And it allows users to enter search criteria to limit the display to show only those items of interest. So for example, they could search for all pumps, or all Alaris 8120 model pumps, or all Alaris 8120s that have a status of available, or all available 8120s located on the 3rd floor ICU. So using this display then and this search criteria, you can limit your listing of what items you're looking for to just those items of interest, including its location and status currently sensed. That location could then be printed or displayed on a mobile device so that the staff can immediately go directly to where it resides. Or if they're using a mobile app that we just saw a moment ago, they'll be able to follow it as it moves through the facility, so that if it moves before you get there, the mobile device lets you track it in real time. So your prey just can't get away from you, okay? Just think about how that tool would benefit your staff who are performing a recall on equipment, or PM, or annual inventory. This changes the inventory project that often takes, weeks to months to complete into something that takes just hours to complete. And think about the impact that would have on your staff and the ability for them to do their jobs well. And you can also forget about the concept of annual inventory. You now have constant awareness of every tracked item, with our software immediately informing you of any items that are no longer in your facility. So we can provide shrinkage and loss management that can even identify the exact time and exact exit that an item left through, setting up the possibility of even recovering that item. We can even automatically send alerts and notifications when the loss is actively occurring to allow you to intervene in real time if you wish. The effort and cost savings of replacing capital assets can be pretty significant. So this is a nice tool to have to put in for that use case. Let's go to the next slide. Oh, I'm sorry, we're already there. Our software watches the movements of your equipment as each piece goes through the various activities that occur each day, so that we can track trends that help you better understand and manage your equipment and workflow processes. We can accurately identify the exact time and duration for each activity, allowing you to reliably measure equipment utilization, and with that information, better understand and manage the proper size of the inventory needed to run your operations. Our in-depth reports and analytics provide all the details needed to make executive level decisions about what you need to purchase, what you can reallocate to another department, and what needs to be rented to manage those seasonal peaks of equipment needs. We can even alert you to exactly when rental equipment is scheduled to be returned and show you exactly where to find it to help you get it back to the vendor on time. And many of our customers have experienced pretty significant cost savings just from that function alone. Let's go to the next slide. One of our more advanced features is our ability to provide PAR management of your PAR storage rooms. And with that, we're able to designate minimum and maximum inventory counts that you wish to maintain for each PAR storage location. This, of course, requires room level accuracy of your hardware technology so that we know exactly what's in each room. And you can then monitor on our dashboard that you see here in real time the accurate counts of each tracked item in each room. And we use highlighted colors to draw your attention to any action that needs to be taken to right size that inventory. For example, showing items that are slightly below par, those that are getting to a critical below par level, or those that have stocked out. We can even show those that have too many items in the room so you can know where to move those from one room to another. Using this as a tool, you can easily avoid stockouts and make sure that your clinical staff are able to perform their jobs efficiently without delays that result from running out of equipment. Let's go on to the next slide. We also can integrate hardware that's able to sense, perform environmental monitoring to sense the temperature, CO2, humidity, and pressure differentials of your various assets, such as refrigerators and freezers that are maintaining medications, vaccines, food, lab samples that have to stay within a critical temperature range, for example, or temperature ranges or pressure ranges for rooms like your OR suites or other sensitive locations. Using specialized RTLS temperature probes, our solution can automatically record the periodic readings from those sensors and alert responsible staff when abnormal conditions exist. This enables them to quickly correct problems before those expensive products and supplies are spoiled. And we also provide this dashboard here that makes monitoring status very easy, as well as the ability to push alerts and notifications to those individuals on mobile devices or to their email or things like that, so that they know in real time when to act. We can also generate comprehensive reports that are required by regulatory agencies to ensure compliance. That takes a big load and burden off of your clinical staff, who often have to interrupt their day to go record readings from these different units in order to meet those compliance requirements. And when a single refrigerator failure incident can result in tens of thousands of dollars of ruined product, it's easy to see how a tool like this could have a very rapid return on investment. We also have the ability to monitor the sensing network so that we can determine if any of your probes or sensors are failing, so that you can repair or replace those before they fail and damage the products that they're monitoring. Let's go on to the next slide. We've also found that once that infrastructure is in place for monitoring these other things, we can easily add on additional solutions that can track patient flow and benefit the clinical side of performance of a healthcare organization. So what you're seeing here is our patient list view that displays all on one screen all the important information that clinical staff need to know to manage the flow of their patients. In the center section, on the left, we can see all the patient care rooms in a department, along with the status of each room. That status is automatically updated every few seconds based on patients and staff entering and leaving those rooms. And if a room is occupied by a patient, then we display the name of the provider, information about the visit type, automatically updated current status of the patient and how long they've been in that status. And we also show the patient's name, age, gender, et cetera, and how long they've been in the facility, along with their current real-time locating sensed location, which may be different than their actual assigned room. You'll also notice on this screen that we use colored highlights to help drive workflow efficiency by alerting staff when some action or next steps need to be taken. We, of course, are using our sensing hardware to identify each location the patient is going into and use our workflow configuration to capture key milestones and key events that are occurring during their visit, so that we're time stamping those and identifying when any of them are running behind schedule or delayed for any reason, so that we can then push alerts and notifications to management or staff to let them know that some action is needed to be taken in that area to make sure the patient flow remains efficient and patient satisfaction remains at its highest possible level. But together, by showing this information on screens and notifying staff when there are abnormal conditions or delays, we're able to optimize the workflow and care coordination that needs to occur between multiple care providers for providing that patient their best optimal care. Let's go on to the next screen. We also have another feature. It's our key performance indicator screen that allows managers to see in a single view the status of each of the key processes occurring in their department. This displays the average amount of time required to complete each of the key activities, such as the time it takes from a patient to go from arrival in the department to being placed into a treatment room, or arrival to being seen by a provider, or measuring the total length of stay, etc. All of these key performance indicators are shown on the screen here, and we use colored highlights to indicate when those activities are on schedule with green colors, or running behind schedule in red, showing the average length of time each is taking, so that management can reallocate resources as needed to improve performance in real time so that they can keep their operations efficient. Let's go on to the next screen. And last but not least, we also have a feature that has powerful current relevance. That's being able to perform contact tracing. With location-based intelligence, of course, we're automatically tracking all the interactions between patients, staff, and equipment to see the path that patient took when they went through the facility, including the people and equipment they encountered. It takes just a few seconds to generate a comprehensive contact tracing report that identifies all the primary and secondary contacts of anyone or anything identified as being positive for an infectious agent. This information can then be used to take immediate containment steps and reduce the spread of infections by isolating and treating exposed individuals and contaminated equipment. So now you've seen several use cases where location-based data can be leveraged to provide a great deal of value to your staff and patients. I hope that now you can better understand the benefits of bringing Infor location-based intelligence into your organization. Megan, I'll hand it back to you to wrap things up.
Thank you so much, Keith. On the next slide, we're going to cover some key considerations. So I have outlined just a few questions that I thought would be helpful for all of you to keep in mind. It is important for you to know, and this question did come up in the chat window. We'll address all the questions in our Q&A portion next, but Infor is what we refer to as hardware agnostic, meaning that we can work with a variety of the different technologies that we've outlined to you today. So to know that is important to understand about the dynamic of our solution for location-based intelligence. With that in mind, we recognize you have a lot of options in front of you from what technology needs to be put in place and what your priority use cases are. It's been my experience that having a solid understanding of your organization's strategic initiatives helps refine down what your priorities are. So you can have alignment between your asks for technology or operational changes and your organization's strategy. It's also relevant to understand what technology you have in place today. What does your Wi-Fi network look like? Do you have any passive or active RTLS technology in use today? A key consideration to know is information such as that, or what mobile devices do your staff carry around? What communication systems do you have in place? Starting with what exists and what works well for you, as well as maybe what the gaps are, is really helpful in understanding what your needs then are. When we take a look at the power of a location-based intelligence, one of the things that it can do is automate manual processes because of the way that it functions. It can reduce errors in data entry because we're automating that process, or reduce errors in communication, or eliminate waste. From a Six Sigma Lean perspective, waste can occur in healthcare in a variety of different ways. There's often 8 types of waste. So thinking through, where is there extra movement? Where is there duplication of efforts? Where am I making additional purchases on equipment? Where am I waiting for information? A lot of wasted time. There's also talent. Am I having staff members or clinicians working at their highest level of licensure, or are they spending time looking for equipment when it could be reallocated to patient care, or looking for equipment when I could have someone in healthcare technology management doing preventative maintenance, for example. You'll also want to understand what data you currently have access to make decisions, and what data you would ideally like to have. Beginning with the end in mind from a reporting perspective and understanding the data that you want to have, then helps inform what kind of solution you need to have in place. And then when you think about your priority use cases, thinking about your key stakeholders in your organization. Organizations make decisions in lots of different ways, and a location-based intelligence solution is dynamic, meaning that it may impact more departments or aspects of your organization than you may think. So if you're in biomed, for instance, there's probably also benefit and relevancy for clinical users that you might want to engage, or operational leaders. It is a software solution with a hardware element, so you'll also want to engage facilities and IT management. So understanding, again, what your priority use cases are and who you might want to talk with at the beginning can help you navigate conversations and decisions in an effective way. These are some questions we thought that you may want to ask yourself. Now we're going to answer the questions that you have asked of us. So I will be facilitating the Q&A portion, and we'll leave you with a slide that shows you just all of our speakers today, as well as our key contact information, so that you can ask questions of us directly. If you want to ask a question during the Q&A portion, please do make use of that questions feature in webinar to type your questions. So we have received a number of different questions. I do hope that I answered one right off the bat with which RFID RTLS technologies does Infor use? We have a variety of best-in-breed partnerships across the range, so I won't exhaust the list today, but if you did have specific questions about something, you can feel free to reach out to us. In this first question here, I am going to actually ask Chris Clemenson to answer this one for me. So Chris, people want to know if you can work with existing hardware that they have in place.
Typically, yes. We, as Megan mentioned, we are hardware agnostic. So we are open to a multitude of technologies. The requirements being that they open their services to be accessible by our platform. Most do in the industry nowadays. So typically the answer is yes, but we would absolutely want to understand that environment better before we can give a firm answer.
All right. Thank you, Chris. And Keith, I think that you'll best address this next question. I'm going to kind of bring together a few questions that came in through the chat window around BLE technology and use of phones and mobile devices. So people want to know how you are procuring BLE technology, if you're using people's phones. And there was also a question about using, say, the GPS technology on people's phones as a locating hardware itself. Can you talk a little bit more about that?
That's a technical question. I'm actually going to hand off to Chris or Derek. I think they're probably better qualified for that because those aren't use case specific. They are more tech.
Yeah, I can start off with the GPS question. This is indoor locating technologies. GPS will not be, the signal's not strong enough to reach through the infrastructure of like ceilings and floors to be useful in locating from that perspective. It is useful outside of buildings, of course, but our use cases are focused inside of facilities. Phones and tablets, other personal communication devices, they are either in production right now for BLE sensing, or they're on our roadmap. So we do have some use cases that use personal communication devices for BLE sensing, and there's more on the way. Was there anything else I can
add a little comment to that. Currently, we're using BLE for proximity locating when it comes to our rounding application called AccuRound, where the mobile device that the observer is carrying with them is sensing the BLE device that may be attached to a patient, so that we can ensure that the observer is in appropriate proximity to the patient when they're performing the observation to validate the accuracy of that observation. So that's one use case that we're currently effectively using that for now. And there's certainly many more that we could expand that into, because certainly all your clinical staff, or a lot of your clinical staff, tend to carry their own personal device. There would, of course, need to be considerations of how we would set up a process of them ensuring that those are on and communicating with a network if we're going to rely on that information for workflow processes that we try to leverage BLE against.
Thank you, gentlemen. And Chris, there is one more question about our mobile applications that you may be able to answer. Someone wanted to know if our mobile application was a third-party app, a native app, or just a browser access on a mobile device. Could you answer that?
Sure. Our applications that we offer are Infor created applications and offered applications, and they are made available through the Google Play Store and the Apple Store. So they are Infor applications. I think that's...
It does. That answers the question. Thank you, Chris. And speaking of Infor applications and software, there is a question here, Derek, you might be happy to answer. Someone specifically asked if there was on the roadmap an interface with location-based intelligence and Infor's EAM. Do you want to share some good news?
Certainly. Yeah, we currently do have an integration built to EAM at this time. And we also have a CMMS, a standard CMMS interface as well that can be used by integrators interested in building integrations between location-based intelligence and their existing CMMS system.
All right, thank you. And there is another question in the chat window. I will go ahead and address. We have customers across the Americas as well as organizations in Australia. Someone wanted to know if we were already available in the marketplace for the EMEA, for the Europe market. And we do not currently have customers in that market. I'd be curious to understand where this person was coming from, and we'd be happy to have conversations with you to better understand what your needs are. And last question here before we close out. There was a couple of questions around, we talked about mobile applications. One of the benefits of having a mobile device, Keith, you spoke to this, was the ability to receive notifications. Can you talk a little bit about options people have for alerts and notifications?
Certainly. So as we're going through the process of identifying the ideal workflow for any particular customer, we can identify those conditions where they want to be notified in real time of potential issues. So we can configure our rules engine to identify the conditions that are appropriate for that and trigger an appropriate resulting action to notify the appropriate individual when that condition exists. To put it in more specific terms, if we have an individual who's responsible for addressing patients who are leaving a department when they should not, we can set up the rule to say when we see that patient leaving, we trigger an automatic alert to that individual that can be pushed to their mobile device or pushed to an email address, etc. We can also, of course, trigger alerts and notifications on our user interactive screens so that they'll be able to see bold alerts on the screen when some action needs to be taken or some information needs to be passed on to them. So that's all highly configurable, and we'll, of course, set it up to work with whatever needs that the individual customer has for as many different situations that they may have in their individual facility that they want to set that up for.
Right. Thank you, Keith. And there was one more question reading through the chat windows. I think it would be either great for Chris or Derek to answer, or I could take a shot at it myself. But in the different technologies, we talked about some of these hardware technologies, the infrastructure and tags emitting frequencies. And there was some curiosity from our attendees about if there are combinations, I guess, that would interfere with the healthcare equipment itself, or if there's pieces of equipment where an active, a non-passive tag should not be attached to. I know that that can get into some pretty specific answers, but generally speaking, what would your advice be?
I'm guessing, Chris, do you want me to go into that? Okay. Well, so we're talking about radio frequency, you know, electromagnetic radiation being transmitted through space. And when you're dealing with emitters of the same frequency, you can sometimes run into interference. Standards-based communication mechanisms such as Bluetooth low energy, passive RFID, Wi-Fi, they're standards-based. They're made to play nice with everyone else that's kind of floating in the air and communicating near each other, either through time slicing technology or through channeling of, you know, everyone gets their own little channel of their frequency bandwidth that they can work within. The 900 megahertz spectrum that RFID plays in or uses is a public band, so it's not regulated. However, there is a standard around it. If you play with the standard, you're fine. However, in healthcare, there are some systems that use that frequency but don't play with that, don't use that standard. So that means your 900 megahertz systems that are trying to run passive could be hampered by existing 900 megahertz emitters in the facility. So it's important as part of the site assessment to do spectrum analysis of your areas where you want to be installing your RTLS system. In general, as part of the site survey, that's one of the first things you want to do is make sure you aren't going to have interference in those areas.
All right, thank you so much, gentlemen, for helping to answer these questions, and to all our attendees for asking them. I will go ahead and hand it back over to Jennifer to close us out.
Thank you all so much, Chris, Derek, Megan, and Keith, for your time today and for a great presentation. I'd like to encourage everyone to visit today's sponsor and to learn more about the services they provide to our industry. Please visit infor.com. A quick reminder that you can obtain your CE certificate by completing the post-webinar survey. This survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE certificate, and you will be able to download the certificate directly from your computer once you submit the survey. If you have any questions, please contact us at webinar@mdpublishing.com. We will be back next week with another webinar. Please visit webinarwednesday.live for more details and complimentary registration. Thank you all and have a great day.